Hi everyone. So in this video, we're going to work through a year 12 question from the AS sample paper. And in this question, we're going to use some equations of normals and also points of intersection between curves. So we have the curve C1 shown in figure 3, and that has the equation y equals 4x squared minus 6x plus 4. So that's the quadratic at the top on the diagram. The point P is the point a half and 2, and that lies on the curve 1. The curve 2, curve C2, also shown in figure 3, has the equation y equals a half x plus ln of 2x. The normal to the curve 1C1 at the point P meets curve C2 at the point Q. So we've got this point P on the quadratic graph. Now, what I'm just going to do, you don't actually have to really do this, but just to show you guys, I'm going to factorize out a 4 from the first two terms of this quadratic. So this would give us 4 times x squared minus 3 over 2x, and then plus 4 at the end there. If you were to complete the square with this, you would be able to work out what that turning point is there. So what I just want to do, I just want to kind of give you an accurate diagram for where this point P lies. But really for this question, it's honestly not that important, but I just want to show you that you can actually accurately work out the coordinates of the turning point of C1. So if you were to complete the square here, you'd end up with x minus 3 over 4 all squared, and then take away 3 over 4 all squared there, close brackets, plus 4. So what you can tell, what you should hopefully be able to tell if you know completing the square, is that that turning point there would be 3 over 4. So this coordinate P has an x value of a half, which is a little bit less than 3 over 4. So really what we've got, we do this in a different color. Let's just say that like half is somewhere there. So the point P is going to be like roughly somewhere there, kind of. So you've got the tangent line, which is this dotted line that I've drawn in there. That's the tangent. But the question's all about the normal line, okay? So the normal line is going to be this perpendicular line. It's not really a straight line, but oh well, it doesn't really matter for the question, to be honest. This point of intersection is the point Q, the intersection point, and we need to find the coordinates of Q. But just before we get into the video, I want to make you all aware about a web app that I have created. Now, this app that you see on the screen here is designed to predict the 2027 Edexcel A-level Maths topics that will come up in your 2027 exams. So now that the 2026 exams have finished, we now have access to those questions. So what I've done is I've analysed all of the questions from 2026 back to 2018, and also including the sample and the specimen Edexcel papers. And I've used that data to put together a model which will predict the topics for the 2027 exams. And if we just scroll down here, you will see how accurate this model that I'm using is. So if you do want to have access to the full predictions for the 2027 exams, and also have access to a web app which will generate mock exam papers based on these predictions, that is what you can get if you do sign up to this app. Just go to the link in the description of this video, and also you can get the link to this web app in my bio. Click that link, sign up. You can see on the top right of the page here, you can sign up. Sign up to the app and you'll be able to access all of these 2027 predictions. Okay, so let's go ahead now then. So really what we need the equation of this normal line. Let's make a note of this. We need equation of normal line. And how do you get the equation of the normal line for a curve? Well, you need the gradient of the normal line, obviously. And how do you get the gradient of the normal line? You use the negative reciprocal of the gradient of the tangent. So what we need, therefore, is we need gradient of tangent. And how do you get the gradient of a tangent to a curve at a particular point? You use differentiation. So therefore, we need to use differentiation. So we're going to differentiate the curve C1. So we've got obviously y equals 4x squared minus 6x plus 4. If we differentiate this using our differentiation method, this will give us an 8x and a minus 6. Now that's the gradient function. We want the gradient specifically at point P. So therefore, gradient at P, we're just going to sub in x equals 1/2. So therefore, the gradient of tangent is equal to, so 8 times 1/2 and then minus 6. So this gives us a gradient of 8 times half, which is 4, minus 6. That gives us minus 2. So therefore, the gradient of the normal negative reciprocal is going to be positive half. So -1 over -2, that is positive 1/2. So therefore, the equation of the normal is going to look something like y equals mx plus c, straight line, y equals 1/2 x plus c. Now we just need to work out what the plus c is going to be. So what you could do to work out the plus c is you could sub in the coordinates of p into the straight line, or you could use the formula y minus y1 equals m times x minus x1. In fact, I'm going to do that here. So I'm going to use y minus y1 equals m and then x minus x1. So x1 is the x coordinate of p, y1 is the y coordinate of p. So therefore what we have is y minus, was it 2, the y coordinate of p? Yes, it was 2. So 2 is equal to the gradient 1/2 times x minus 1/2. There we go. So we have y is equal to, expanding the brackets here, 1/2 x and then minus 1/4. And then if we move the 2 from the left side over, we get plus 2. So therefore, equation of normal is going to be y equals 1/2 x, and then 2 take away 1/4. That's 8/4 take away 1/4, which gives you 7/4. Just another quick interjection. If you are currently doing Edexcel A-level Maths and you feel that you're struggling or you're falling behind and you're not quite getting that grade that you need to get in order to get into university, or perhaps you're a parent watching this and you're worried about your child's progress, what you can do is you can head to my website. Now, my website is in my bio and also in the description of this video. Click onto the link and you can watch a brief video about me and my background. You see this video on the screen here. In this video, I outline the style and the structure of my tuition. You can also read some of my reviews and testimonials from other parents and students who have worked with me on this website too. So if you feel like one-to-one tuition is something that would benefit you in order to get the grades that you need to get, then again, just head to this website. And what you can do is you can book a free 90-minute call with me. And in that call, we'll spend some time discussing you, your situation, your ambitions, what you want to achieve, the grade you want to get, and why you feel like you're struggling and why you feel like maybe tuition is the right path for you. And we'll also spend some time basically doing a free trial lesson where I will help you out for free with any particular topics or any particular areas of the syllabus that you know you need help with. And by the end of the call, we can then discuss whether one-to-one tuition is the right path for you to get you that grade you need to get. So once again, the link to my website is in the bio and in the description of this video. Perfect. So we've got the equation of the normal. So now we know the equation of this kind of blue line here. Let's just highlight that in blue. So this is y equal to 1/2 x. And then was it minus or plus? I think it was plus, wasn't it? Plus 7/4. Oh, scrolled up too far there. There we go. Plus 7/4. So now we're finding the intersection point between the line and the curve. This curve here, 1/2 x plus ln 2x. So let's just scroll down now here. So now finding Q. So we've got again that line, and we're finding where that line intersects with this curve. Because both curves are given in the form y equals a function of x, we can just set the two functions equal to find our points of intersection. So we can just set the y coordinate of the line, 1/2 x plus 7/4, equal to the y coordinate of the curve, which was 1/2 x ln 2x. 1/2 x plus ln 2x. Now you'll clearly see that if you take away a half x from both sides, the half x will just disappear. So you have 7 over 4 is equal to ln 2x. Now we're trying to find x, of course, that's the x coordinate of q. So what we have to do is we have to get rid of the ln. We have to inverse the ln. And what is the inverse of ln? It's e. So raise both sides to a base of e. So therefore, e to the power 7 over 4 is equal to 2x. And now we can divide by 2. So x is equal to 1/2 of e to the power 7 over 4. Now, let me just check. Did we need to find the y coordinates as well? Yeah, it says here, find the exact coordinates. So firstly, we found the exact x coordinate because that here is an exact value. We've not gone to the calculator and rounded it. That is an exact value. So we leave the x value like that. So now we need to find the y value. Now find y value for q. So what we just do is we just sub in that x coordinate we just found into either the curve, C2, or the line. I think it's probably easier to sub into the equation of the line, the normal line. So we're going to sub x equals half e to the 7 over 4 into normal. So the y value is going to be a half multiplied by the x value, so multiplied by half e to the 7 over 4, and then plus 7 over 4 for the plus c. So then this gives us 1 over 4 e to the 7 over 4 plus 7 over 4. And so therefore our final answer for q, the coordinates of q, the x value is half e to the 7 over 4, and the y value quarter e to the 7 over 4 plus 7 over 4. And those are the exact coordinates of q. Now, if you do have any questions, do let me know in the comments and I will try to help you out if you do need any help. But hopefully that all does make sense.